Okay, so for today's lecture, as I inform you, we will have 2 hours, but with different teachers and with different link. So I will give the materials until the mass and heat balance, and then later Pak Hendra will continue to the designing of the steam steam system. Okay, maybe I just start from what have been Pak Miki's explained in previous lecture. So basically, there are 2 types of steam system diagram. The first is the classification or steam system diagram based on the the equipment grouping. So in this diagram, each equipment, the equipments are grouped or classified uh, based on the component. So like boilers and steam generation process is grouped together, and then the turbines are grouped together, and then condenser turbines is grouped together, and then steam consumers are grouped together. And then each line represented the type of the pressure of the steam that these equipments is using. So normally the flow is rotated clockwise, yeah. So from the left to the right to the bottom and to the left, something like that. This is the steam diagram that that is made based on the equipment group. Okay, and the second one is the steam diagram based on the pressure. So each different equipment, although they are different equipment, but if they are using the same types of the steam, whether it's high pressure, medium pressure, or low pressure, are grouped separately. So those equipments that are using higher pressure are grouped together, and then using medium pressure used together, and then grouped together, and the low pressure also grouped together. So we call it the pressure ladder diagram, because you see the construction is like a ladder, yeah, tangga, and each ladder will have different pressure of steam. Yeah, this is diagram of this steam system based on the pressure ladders. So you can see this is the steam header. Yeah, each line is the header, which is the steam header is basically is horizontal lines. Yeah, and then group based on the steam pressure from the top to the bottom. Yeah, the top one is the highest temperature, highest pressure of the steam, and then from the highest pressure, the steam will be used by equipments that using this kind of pressure, yeah, this kind of steam. And then after being used by this equipment, of course, the pressure will go down, right? Of course, the pressure will go down, but it still have some pressure. So these types of steam can be used by the next equipment, and then it will goes down again, and then it will be used by the equipment using the low pressure. So this is the basic of the steam ladders, and each ladder represent the steam header. This is the steam header. The picture is the steam header. So the equipment, yeah, that use the steam at certain pressure will be placed under the relevant steam line. It means it will be depending on the value of the pressure. Yeah, and then the steam will be distributed to relatively large size lines. Yeah, essentially a very long pressure vessel. So basically, steam header is a pressure vessel. Yeah, it's a tank, but the physical form is a pipeline, yeah, but basically it's a tank or it's a pressure vessel. Yeah, this called steam header, where each header is designed to handle different pressure. So basically we have high pressure, medium pressure, and low pressure steam header. Okay, yeah, from this steam ladder, you can see the equipment that producing steam will be placed at the top. Yeah, the boiler plant, because the main source of the steam is the boiler, right? So this is the boiler, or maybe steam can be produced with the cogeneration unit, and then also another with heat steam generator if available. So basically, in the plant, yeah, at the plant, you must design first what will be the highest pressure of the steam required. Yeah, whether should it be the high pressure, or should it be the very high pressure, or maybe you just need medium pressure, or you just need low pressure. Yeah, and then the highest pressure, yeah, the highest steam pressure is basically should be can be produced by practical equipment. I mean, if possible, just use one boiler. So one boiler should provide steam with the pressure, with the maximum pressure required at those plant. Ya, jadi idealnya ya, atau paling mudahnya itu adalah satu boiler ini bisa menghasilkan steam dengan tekanan atau kondisi yang paling tinggi dari yang dibutuhkan di pabrik tadi. So it's not like each steam header is provided by one boiler. It's not practical. Yeah, the practical one is like this. So all the steam producer unit should be able to provide steam with the maximum characteristic of steam required at that plant. And then the steam will be used by the subsequent equipment. That subsequent equipment will be used the steam, and then the steam condition will be lower, right, after being used, and then it should be able to be used by another subsequent equipment that using the lower pressure of the steam. Dan seterusnya. It should be like that, so that you can draw the steam diagram based on the pressure ladder. And then later at the bottom, after steam is being used, it will become condensate, right? So at the bottom, it will be the condensate heater, where all the condensate are collected together. Okay, now how we choose the steam condition, because this is the main consideration first, right? The steam condition will be influenced by first the setting steam pressure of the pressure and the temperature. Yeah, steam condition will be influenced by this, right? The pressure and the temperature. So we can decide at this specific plant how much is the pressure and the temperature that we need to have for the steam will be influenced by first, of course, the characteristic of the turbine, because this is the main equipment that will use the steam, right, as the fuel, or as the mover of the turbine characteristic. And then beside the turbines, the consideration of the steam condition, or steam pressure and temperature, it will also be influenced by the target temperature for the process that required heating. Yeah, because steam it's not only used for moving the turbine, but also it's used to heat it some process, because maybe some process required higher temperature, or maybe heat exchangers required hot temperature, right? To sterilize some bahan, some raw materials. Then the target temperature should be considered as well to select what kind of steam that we need to produce. And then the selection of steam condition will also be influenced by the boiler feed water supply cost. Also, it will be influenced by the piping materials and thermal efficiency of the process. Okay, before explaining each of the point, maybe just remind you again about the boiler feed water, right? When we discuss about water supply in the process, I think you can still remember what will be the differences if we are using low pressure steam with compared to high pressure steam. Yeah, the condition of the water that we need to provide for this kind of steam is different, right? For low pressure steam, maybe treated water is enough. Yeah, treated water is enough. But if you want to go to the high pressure steam, then you need to use the demineralized water to avoid the corrosion, to avoid the scaling, etc. Because when you increase the temperature, of the water, the possibility of the corrosion, the possibility of the scaling is also higher. So comparing treated water and demineralized water, it will require different costs, right? So this one is one of the consideration. And then selection of the steam condition based on the turbine characteristic is basically it's really important if the turbines is the condensing turbines, because it will create some condensate, right? So the steam that used to drive turbines, we usually call it motive steam. I don't know the term in Indonesian. So for the condensing turbines, especially for the condensing turbines, the liquid fraction of the steam is one of the important parameters that we need to monitor. Yeah, usually the amount of the water is not more than 15%. Yeah, then for the high speed, it cannot go more than 10%. So do you know why we need to pay attention about the amount of the water in the steam, especially in the condensing turbines? Why, if we increase the speed, the liquid fraction of the steam should be as low as possible? Hello? Anyone want to try to answer?
Sir, is it
Yes.
something about water hammer?
Yes, it's like water. Well, basically, I don't know the term whether it's same with, but it's, yeah, it's like water hammer. So because if you have the steam turbine, when they rotate, right, and if the speed of the rotation is higher, and if you have more water in the steam, it will create benturan, yeah, collision between the impeller or the something that rotate inside the turbine with the water, especially when the rotation is happen at higher speed. Yeah, it's like water hammer. If you have more water, then it will damage the impeller. So we cannot have a lots of water fraction, liquid fraction in the steam. Okay, then if the condensation pressure and also the turbine efficiency, yeah, I think you have learned about how to calculate the turbine efficiency, and then the condensation pressure is also known, and then you can calculate what will be the condition of the steam that you should give to the turbine. Yeah, you can use the steam table, the steam curve, and then from the thermodynamic data, you can decide what will be the inlet steam condition. And then you can choose what type of steam that required in this process. Okay, any question until this point? Hopefully I can answer. Ada pertanyaan? Okay, if there is no question, then I'll go to the next slide. The other consideration is the process steam temperature target. Yeah, like I have said before, steam is not only used for the turbine, but maybe it will also used for the heating process or process heating. We call it heating steam or thermal steam because it's for heating, right? Yeah, and what you need to consider first is what will be the temperature of the process that you require. Ya, berapa kondisi temperatur yang harus dipenuhi untuk proses tadi. That should be achieved, right? So after you know the temperature target, ya, the target of the temperature from the process, and then the temperature of the steam, yeah, should be higher. Yeah, because you can imagine, right? Before the steam entering the equipment, yeah, the equipment of the process that required heating, it will goes to some pipeline system, and then it will have, yeah, even though the pipeline is insulated, then there's some heat loss happen, right? So the condition of the steam will decrease, the temperature of the steam will decrease. Also, I think you already got the heat exchanger module in your lab tech, right? And you have learned that when the heat is being transferred, like from steam to the cold liquid or cold materials, there will be some efficiency of the heat exchanger. Yeah, the efficiency of heating transfer is always not 100%. It will be less than 100%. Yeah, so there will be some temperature decrease. So the one that you must pay attention first is what will be the temperature that you required for the heating process. And then the steam temperature should be above that. Yeah, actually there will be some calculation to calculate, to predict what will be the temperature of the steam, but as the rule of thumb, the steam heating, the minimum, yeah, the delta between the process temperature with the steam temperature is around 20 degree Fahrenheit or 11 degree Celsius. Yeah, this is the rule of thumb, but actually you can also calculate, yeah, but it will be depending on the how long is the pipeline, what will be the heat loss during the steam transfer, yeah, from the steam header to the equipment, yeah, to the heat exchanger, for example. How long is the pipe? What will be the condition of the insulation? What will be the heat loss during the transfer? And then what will be the heat loss during the transfer in the heat exchanger? Yeah, then you can calculate back, yeah, from the process temperature into the steam temperature. Okay, this is the rule of thumb. And then the process steam, yeah, or the heating steam, generally is produced and distributed in superheated condition. Although maybe the degree of the superheated will be lower than the motive steam. Motive steam is for the turbine. Process steam or heating steam or thermal steam is for the process. Why we need to produce in the superheated condition? Anyone can think of the reason? Halo? Kenapa? Steam untuk proses itu sama ya seperti steam untuk turbin, itu didistribusikan dalam bentuk superheated. Bukan saturated, tapi superheated. To avoid what?
Less tendency for liquid to form, sir.
Less tendency for?
For liquid to form, to prevent the one just now
If you
said, the
have
water
liquid,
hammer.
Yeah, because it's to minimize the condensation. Yeah, it means to minimize the production of liquid, because one can create water hammer first, and then the second one can create more possibility for corrosion. That's why generally, steam is produced in superheated condition. Okay, the other is the consideration related to the piping materials. So the choice of the piping materials will be depending on the pressure of the steam. Yeah. One consideration when you choose the materials for the piping is based on what types of the steam that you use. What types mean what is the temperature. Yeah. If you are using around or below 640 bars or 600 psi, yeah, for the steam, carbon steel is okay, still okay, yeah, because for low or medium pressure steam, the possibility of corrosion and then the possibility of the condensation is low, then the carbon steel can be used. But for the higher steam, yeah, for higher steam pressure, like 900 of 1500 psi, normally we are using the alloy. Alloy means you will have I forget this. This should be percent of mass. I think you already got Bacon, right? So when you get the number like alloy with 0.5 carbon and 0.5 molybdenum, and also if you are using 1500 psi alloy metal, 1500 psi steam, you should use the alloy with 0.5 chromium and 0.5 molybdenum. You know what it means, right? What it represents the concentration part or part of the mixture of these metals to the iron, ya. Dari besinya itu berapa persen? Okay. If you go for the higher pressure steam, then higher content of alloy is required. It means the price of the pipeline system is also become more expensive. Yeah, this should be considered as well. So it's not only a matter of the corrosion or a matter of the condition of the steam, but it will also require more expensive steel for the pipeline. And also during the pipeline or along the pipeline, steam lines is always insulated. Yeah, it's not only for the heat loss reduction. Yeah, so it's always insulated. It's not only for the heat loss optimization. Yeah, because we cannot avoid heat loss at all, but we can reduce the heat loss using the insulation. But also for safety, because the steam is very, very hot, the pressure is very, very high. So the insulation comes as the safety or the protection for the pipeline. In case maybe there's some leaking in the pipelines or maybe some rupture in the pipelines, the insulation materials also act as a barrier for the pipeline. Okay, and then the selection of the steam condition will be based by will also based on the efficiency of the system as well. Yeah, the overall efficiency of the system. For example, I think you have learned about the cogeneration, right? The efficiency of the cogeneration basically will be based on the steam diagram. Yeah, the diagram of pressure and the temperature. You can see that the cogeneration, if you have cogeneration system, this efficiency will increase if you have higher temperature and higher pressure of the steam. Yeah, you can remember again from the shape of the curve. Yeah, and then but if you go for the higher steam and the temperature, then what we have been discussed before, yeah, the boiler feed water cost will be higher, and then the pipeline cost will be higher. Yeah, so basically, generally, yeah, I mean, a plant usually have 3 stages of the steam pressure, like we have seen before. Yeah, we have high pressure is around 600 psi. It's normally used for the turbine, yeah, for the production of the mechanical energy. And then the medium pressure is around 150. It can be still used for the turbine, but for the small turbine, or we call it the small or the emergency turbine, and then for the steam tracing, yeah, to trace the steam flow, and then also for heating process or process heater. And then the lower one, the low pressure steam, is normally used for the process heater. So I think in diktat and also in this slide, you can see different types of plant. Yeah, we have LNG in Bontang, and then oil refinery, and then polymer, and then pepper. Yeah, also the palm oil. You can see what will be their requirement for the steam condition. Yeah, various plants. This is the example of various plants using different steam condition. Some use high pressure, medium pressure, and low pressure. Some only use the medium and low pressure, and some only use the high pressure and also with low pressure. So depending on the demand of those types of plant. Okay, any question until this part? Okay, if there is no question, maybe like this one. Okay, this is the steam ladder. Yeah, each ladder represent the steam header. Yeah, and in steam header, you will have the pressure indicated. Sometimes it will also represent the temperature, and then also represent the heat content, heating value, or the enthalpy of the steam. Okay, then if you see something like this, yeah, what will be the pressure of this turbine? In this part of the turbine, you have see 3 turbines, right? What will be the pressure of this turbine?
Sir, you mean the processing pressure?
Sorry?
Do you mean the processing pressure of the turbines?
Yeah.
Maybe somewhere near 600, sir? Or
Yeah.
like, yeah, somewhere, yeah.
Yeah, because basically this steam ladder, yeah, diagram of steam system based on the pressure ladder is basically to simplify the condition of the equipment related to the steam condition. So all the steam coming to the equipment, or all the flow of the steam coming to the equipment, yeah, from the steam header, or all the stream coming to that steam header will be the condition will be the same as the steam header. Yeah, it means this steam comes from the waste heat steam generator, cogeneration, and then boiler plant will have 600 psi of the steam. As well, for the steam go to this turbine, it's also 600. For this one is 150. Yeah, and etc. So that's normally how you read the steam ladder. Okay, and this video shows you, right? So basically why we write the steam diagram into the steam ladder is basically like this. You have high pressure steam. It will be used by the equipment that using the high pressure, and then of course after being used, it will be the condensate, right? There will be some part of the liquid into this in the steam, so it will goes to the separator, that will flash the steam with the condensate, separate the steam with the condensate, and then the steam will be goes to the lower pressure ladder, and it will be used by the steam using equipment that using the low pressure. Okay, any question?
Sir,
Yep.
in the steam header drawing, we don't. I mean, we couldn't see the flash. Yeah, the flash things. Then, like, is it included here somewhere, sir?
I think in the steam ladder, it's just drawn by the one line like this one, right? So, but this is not the flash. But I mean, any line that goes to the condensate header will be some of the condensate will comes from this flash. Ini memang tidak akan digambar di steam laddernya. Tapi harusnya sih ada garis yang menunjukkan nanti aliran kondensatnya dari mana saja. This one, right? Like from tank heating, from pipe tracing, from process unit heating, it will create the condensate, right? So there will be also one line of the condensates comes from the flash tank. I think something like that.
One more question, sir.
Yeah.
If one of the steam headers is, for example, 180 MU, sir, or atmospheric pressure, if it's atmospheric pressure, do we still need to draw?
I think there is no steam header with have 180 m pressure.
For example, if you like calculate the amount of pressure inside, if you need a certain processing pressure and somehow you get 180 m, do you still need to draw, sir?
I think it won't be in the steam header because steam header is normally only like medium, high, and low pressure. But in some cases, if you have or if you need the pressure of the steam is lower than the steam header, usually it will be accommodated with the like this one, yeah, like the either is the flash tank or maybe the superheater to lowering the pressure. So it will go. It will not goes to the steam header first, but there will be some equipment that how to say this. Yeah, the principle is like the flash tank, like separate the condensate part of the steam, and then steam with lower pressure, which goes to the steam using equipment directly. For the 180 m, I think it will not go to the steam header. Is that answering your question?
Yes. Thank you, sir.
Okay. Any other question? Okay, if there is no other question, now we will see the construction of the mass and heat balance of the steam system. But basically, this is the simple mass balance, right? Because actually, the construction of mass and heat balance for the steam will involve like turbines. Yeah, major equipment is like turbines, boiler, pressure relief valve, the superheater, the aerator, heater, and the steam header. But in this lecture, the calculation of the mass and heat balance, we will only determine the steam flow rate, and then the water flow rate, and then the turbine output power, heat flow rate, and then heat flow rate for process, and also heat flow rate for the boiler. Okay, the thermal efficiency of the boiler or the internal efficiency of the turbine can be assumed to be constant or as a function of load. So it's not changing if we change the flow rate or we change the types of the steam. So this is the diagram or the example of the steam usage in the steam ladder diagram. Yeah. So this is the steam system for producing work and heat in the picture of the steam diagram. in this diagram, we have a boiler. Okay, boiler sometimes drawn under the first ladder to minimize or to optimize the space of the drawing. Okay, and then we have one turbine, yeah, one turbine, and then we have 3 steam header, 150, 1500, 600, and 50, and then some process and deaerator. So we have 3 stages of steam pressure. The condition is as follows. The very high pressure is 1500 psi, 800 Fahrenheit, and this one is the enthalpy, yeah, the specific enthalpy. And then the high pressure is 600, 500 Fahrenheit, and then the low pressure is 50 psi and 281 Fahrenheit. Okay. The condition of the low pressure is the saturated steam. Yeah, and this box, yeah, this box represent the superheater. So the superheater, so the ladder, the first ladder and the second ladder represent the very high and the high pressure, right? The condition of this two steam is superheated, and then after from the second ladder, it will goes to the superheater. Yeah, the superheater. The superheater will create saturated steam from the superheated steam by mixing it with the water. So the water comes from the aerator that goes into the pump. Yeah, and then from the first header, it will goes to the turbine, yeah, in flow A, and then from the turbine, it goes to the second ladder, and then from the second ladder, it will goes to the to be exported and also to the process heating. And then from the second ladder, it will goes to the third turbine, yeah, the third turbine, and also goes to the superheater. Okay, this is the representative of the steam diagram. And this is the condition of the steam. Yeah, the extraction turbine, the total work will be 20,000 horsepower. And then at first stage, the actual stream rate is 30 pounds per horsepower hour. And the second stage, this is 8 pounds. Okay, the flow rate is like this, yeah. The flow rate of the steam exported, yeah, this flow is 100,000 pounds per hour. And then to the process is also 100,000 pounds per hour. This flows goes to the other places, yeah, either to be exported or to be into the process. It means it will goes back to the steam header. Ya, jadi yang dua ini pergi gitu ya, tidak kembali lagi ke steam header. So it means we need to have make up water. The air tambah is the make up water. So the flow rate of the make up water will be the summation of these two. So it's 200,000 pounds per hour. Okay. Yeah, this is the that we have that I have asked you before. Yeah, the condition of the steam from or to the steam header is assumed similar to the steam condition at steam header. It means the steam condition at flow A is 100 psi, steam condition at B and D is 600, and steam condition and at turbine outlet, yeah, T3 outlet, and steam outflow from the superheater is also 50 psi. Yeah, because it goes to the 50 psi steam header. Don't forget, I think you got it in McFlu class, right? Because sometimes the number in this one is in gauge. It means you have to add the atmospheric pressure for the calculation. But for this one, it's already in absolute pressure. Yeah, just pay attention about the unit of the pressure, whether it's in gauge or absolute. For the calculation, use the absolute. Okay, the other steam condition, the make up water, yeah, the air tambah, is 15 psi. This is the temperature at the enthalpy, and you can also calculate it from the table. And then the condensate from turbine T2, yeah, this one is saturated liquid with this pressure and temperature and also the enthalpy. And then the boiler water exiting the deaerator and fed to the pump is this one, is 15 psi. And then the temperature and the enthalpy is explained as well. And then the boiler water, yeah, boiler water is the water that goes into the boiler, is the subcooled liquid with this condition. And then the enthalpy due to the pumping, yeah, because maybe it can change the enthalpy, but for this one, the calculation, we can assume it's the constant. Okay, so basically you just in each flow you can make the balance, yeah, the mass balance of the extraction turbine. So it means the flow rate, mass flow rate at A will be the summation of B and C. So the energy balance is this one, right? So you divided the flow rate by this one, you divided the work by this one, yeah, the actual steam rate, this one. And then for the mass balance, yeah, in the steam header of 600, it contains flow of the B, and then flow of the process, flow of the D, flow to the turbine, and flow to the exported line. Yeah, just do all the calculation, and then the mass balance is for the 50 psi header is also can be constructed same as the 600 psi header. And then you have the mass balance of the deaerator, energy balance of the desuperheater, yeah. Yes, so you just multiply the flow rate with the enthalpy for the energy balance, and then also energy balance of the deaerator. Any confusion how to construct this steam balance?
Oh, sir, do
Yes.
you mind going to page 18 because I didn't catch up on note taking before.
Oh, this is this one.
Yeah,
This is the data, still data.
yeah, I missed it before
Oh,
because
oh,
the PPT is not on EduNext yet, I think.
oh, I have sent it in the group.
Oh yeah, in the WhatsApp, right?
Okay, but I think I have uploaded in the EduNext, but I don't know whether EduNext is working or not.
Thank you, sir.
Okay. This is the condition, still the data. Because we have make up water flow, and then the aerator flow, and then boiler feed water flow, and also this one, this one. Yeah, this one is the condition after the pumping. Yeah, the aerator, after from the deaerator, it will be pumped. The flow is separated to the desuperheater and also to the boiler. Do you have any question about this information, Dama?
No, sir.
Okay.
Sir, I have a question, sir.
Yeah, sure.
Oh, what does that stop mean, sir? Right before T3?
Which one? Which one?
That one,
Oh.
sir, before T3. Yeah.
This one, is it?
Yes, sir. Why is there stop there?
Oh,
What does
this
it
is
mean?
the valve. Like the flow for this turbine, it's like can be regulated, right? Whether you want this T3 to work or not, yeah, by adjusting the stop valve.
Oh, okay, sir. And also, sir, the one before, the T1 and T2,
Mm-hmm.
why do you have to divide it into two parts? And is that relating to like two different temperatures or something, sir? Like I understand where
Yeah.
as you expand more, then it turns into liquid, and part B is like in the middle because you want more pressure. You want that required pressure, right, sir? Is that right?
Yeah, it's basically the extraction turbine works by dividing the turbine into two stages, right? And each stage will have their own, they will produce different types of steam or condensate. Like this one, because you have different steam rate, yeah, different steam rate. Then since you have total work, yeah, total work is for the whole turbine, and then you separated the turbine into two step. It means each turbine can work, how to say, it's not independently, but to subsequently, yeah. So by adjusting the steam rate for each step, then you will have different types of steam, and also you will have different flow rate. It means you can provide two types of flow, two types of steam.
Does it mean you can divide it into like more components and more parts, like depending on what pressure you need?
Yeah, you can produce more than one types of steam. That's why we call it extraction turbine. It's basically just adjusting the flow rate and then adjusting the work. So at B, you will have higher pressure, medium pressure, yeah. But at C, you will have water. It's like separated steam and water. That's why we call it extraction turbine.
Okay, sir.
Okay.
Thank you, sir.
Okay. Okay, now we go back to the construction of the steam balance. Yeah, basically you just write all the, see the equipment, yeah. The equipment will be the titik awal itu apa ya? As the beginning point of the balance calculation, yeah. Like for this one, you can construct the mass balance, and then you can construct the energy balance. At the steam header, you can construct the mass balance. And then at the T3 and the superheater, you can construct the mass balance and also the energy balance. Then what you need to do is to check how many numbers of the variable that you need to solve. How many unknown variables? Yeah, variables here is the mass flow rate. Yeah, you will have from A to F, right? From A to F, so you have 6 variables. Yeah, from MA until to MF, but you have 7 equation. So it means you still remember, right, about the degree of freedom. Yeah, if you have 6 variables, it means you only need 6 linearly dependent equation. Ya, kalau Anda punya 6 parameter untuk diselesaikan, berarti Anda butuh 6 persamaan bantuan gitu ya. 6 persamaan bantuan di mana 6-nya itu harus linearly independent. Ya, linearly independent. So possible cause why we have more equation, maybe one equation, maybe some of the equation is dependent to one another, or maybe actually there are 2 same equation that's so one of the equation is redundant. So like you write the same equation twice, something like that. So this kind of equation maybe comes from one equation resulting from the multiplication of other equation, and then equation resulting from the addition of addition of 2 or more other equation. Yeah, for example, in this one, the steam header 600 steam header is not included in the previous equation because it's clear that the energy balance of this header is obtained from the multiplication of mass balance and steam enthalpy at the PT condition. So it's the information that we can get from the steam tables. So we do not need to calculate from other equation. And then also we see that equation 5.6, yeah, it's the combination of equation 5.1, 5.2, and 5.4. So 5.6 is dependent. Yeah, so we can omit this equation. This equation cannot be used to solve the balance. So this is the challenge for you, yeah, after you construct all the balance, yeah, the mass and energy balance, you have to decide if the degree of freedom is not 0, then you have to decide which equation should be omitted. The equation that should be omitted should be the equation that is redundant or depend from other equation. So later you can only have 6 linearly dependent equation. Okay, how to solve is basically, yeah, just use your creativity, yeah, to do the elimination and substitution method. Then you will get the value of each mass flow rate. Okay, I think since it deals with the calculation, I hope you can try to redo the calculation so you get used to the concept, and then you can familiarize yourself to construct the balance, and then try to check which one or which two of the equation that is not needed to solve the mass and heat balance. Okay, any question? Ada pertanyaan? Okay, I hope you get the concept. Yeah, I'm sorry if I'm not clear enough explaining you about the concept. But since I have another class at 9, so the rest of the materials, yeah, design of the complex steam system will be explained by Pak Hendra at 9 o'clock class. So thank you for today's, and hopefully you can doing well for tomorrow's exam. Okay, please move to the another Zoom link for Pak Hendra's class. Okay, good morning, stay healthy, and bye-bye. Thank you.
Thank you very much, sir.
Thank you very much, sir.
Much, sir.
Thank